So we're going to add and subtract rational expressions with a common denominator, and I'm hoping, I really am, that you remember how to add and subtract fractions with a common denominator. Let's say I had 3/4 and I had 2/4. How many quarters do I have? Is 5/4, and that's the same as if I had 3 cats plus 2 cats. I would have 5 cats. And my point is, as long as you have the same denominator, you're combining like terms essentially. I have 3/4 and 2/4, which is 5/4. 3 cats and 2 cats, so 5 cats. So what we're going to be doing here is we're going to be doing the same exact thing, and the only difference is we're going to be using rational expressions. So here I have, check for a common denominator, and I do have a common denominator. It's y squared minus 4. So it's combined like terms in the numerator. So I'm going to write it as y plus 2 over y squared minus 4. It's subtracting to distribute, but we weren't subtracting, so I don't have to worry about that. Keep the denominator the same, which I have. And then factor and simplify if possible. So I can't factor the numerator because it's already factored, but I can factor the denominator. And when I do that, I get y plus 2 times y minus 2, because it's the difference of perfect squares. And now I'm going to simplify. Those are going to cancel out, and I'm left with 1 over y minus 2. Now, it's always possible that you're going to have something like this, x minus 5 minus 4 over x minus 5. And if you do this, you're just going to get z minus 4 over x minus 5. There's nothing to cancel out, and you're done. Now, I'm going to do another one. Let's try another one, and I'll do it up here. And it's going to be some good stuff here. I'm going to say, let's say I had something like 4x plus 1 over 2x plus 3x plus 2 plus 6x minus 3 over 3x plus 2. I can combine my like terms in the numerator, so it's going to be a 4x and a 6x. Oh, well, I checked 3x plus 2 and 3x plus 2. Good. So my denominator automatically is 3x plus 2. It's going to be 10x, and that's going to be minus 2. I can factor again, and I get 5x minus 1, but I still can't do anything in my denominator. So my denominator stays the same, and that's my final answer. I'm going to show you this subtraction one. Let's say I had something like this. Let's say I had, let's see, where would be a good subtraction one? How about x squared minus 2xy over x minus 2y minus xy minus 2y squared over x minus 2y. Now, I have a common denominator, so it's going to be x minus 2y is my denominator. Now, the key here is I want you to pay attention to this. Ooh, this looks like it's going to be a beautiful shade of blue. I'm actually subtracting this whole quantity, so I have to distribute that negative sign across. So I'm going to be left with x squared, because it's the only x squared I have. I have a negative 2xy minus xy, which gives me a negative 3xy. And then plus 2y squared. Now, I'm going to do some scrap work over here. And if I do this, I'm going to say, well, I know that this has to be x and x. And I know that one of these has to be a 2y, and the other one has to be a y. And because this is positive and that's negative, the sign should be the same. Let's just double check. If I FOIL this out, it would be x squared minus 2xy minus xy gives me negative 3xy, and then plus 2y squared. So that does work. So when I factor, I'm going to be left with x minus y, x minus 2y. Oh, but that's good luck, because take a look. Now, I can strike this one down and this one down, and my final solution is x minus y over 1. Alright, that's it. I hope this was useful. If you're a little unsure, watch it again. Take a look at your notes. Good stuff, good stuff.